In Chapter 5, what we're really looking at is a set of skills that we're going to use in the upcoming chapters in the Intermediate Accounting 2 class. And those skills relate to an understanding of the time value of money. So while there's not any particular sort of accounting debits, credits, those kinds of things that we're going to do in this chapter, we're going to utilize the calculations that we learn in this chapter in applying those calculations in chapters 14, 15, and 17. So at the sort of very basic understanding, the time value of money simply means that a dollar today is not the same as a dollar in the future because of the earnings potential. So if you have a dollar today, that is worth more than a dollar, say, 1 year from now, because in that year you can take that dollar and you can earn a return by investing that dollar. And the type of investment and that sort of thing doesn't really matter for the basic sort of conceptual understanding that we're getting down to here. And so what we have to understand and why this is important a lot of the times for accounting purposes is because there are some instances that we're going to come across, like I said, in chapters 14, 15, and 17, where we're discussing liabilities that an organization has, but those liabilities are very far down the road into the future. They're long-term liabilities. And so what we have to be aware of is that those long-term liabilities that are way far out into the future, the value of that future dollar is not the same as the value of that amount in today's dollars, again, because of this concept of the time value of money. So why we have to be, or why we're sort of learning about this concept in intermediate accounting is because when we get into a discussion about those long-term liabilities, we're going to have to understand and perform calculations that will take those future dollars that are, again, they're liabilities that we have way out into the future, say a long-term note or a long-term lease or a long-term defined benefit pension plan. Those are way out into the future. And what we have to do is understand what the future amount is and then perform calculations to bring that future amount into today's dollars, because the fact of the matter is that we have to prepare financial statements as of a certain point in time, not 20 years out into the future when the lease payments are going to have to be made, or not 30 years out into the future when the retirement benefits are going to have to be paid. We have to report that liability on our accounting records today. So again, we have to take those future values and we have to sort of morph them into what they're worth in today's dollars. And that's what we're going to learn about in this chapter. So to begin the conversation, we talk about compounding interest. So there's a difference between simple interest and compound interest. Simple interest is when we have an initial investment, we have an annual return on that investment, and we calculate those earnings based on that annual return. So if I jump over into my Excel spreadsheet, you can see that in the top left side of my Excel spreadsheet is where we're looking at simple interest. So you can see the big thing to take away when it comes to simple interest is the fact that when we at the end of a given year, right, we accumulate a year's worth of interest, which in this case, if we were investing $1,000 and we were earning 6%, the amount of return that we would have earned would have been $60. But notice, then we go back to the initial principal balance, and we again earn 6% on that amount, and then in year 3 again we go back to that initial principal amount. We don't sort of add to our beginning principal amount when we're talking about simple interest. We only look at and we only earn a return on that initial amount that we invested. So again, that's simple interest. We look at the initial investment, and that initial investment is the only amount that we earn a return on. Versus compounding interest. Compounding interest is where we start with an initial investment, but over time we start to accumulate a return, and then that return then becomes part of our initial investment. So year over year we start adding to the principal balance of what we're earning. So again, jumping into my Excel spreadsheet, we can see that the compound interest on the right hand side of our Excel spreadsheet, notice after year one we have the same amount of interest earned that we did in year one with simple interest. We have that $60 that we've earned in that first year. But then what happens is that $60 then gets added to the principal balance of our investment, and we start earning interest not just only on the initial $1,000, but then on the $60 that we're adding to that principal. So that after year two is over, we've actually earned, instead of only $60 of a return, we've earned $63.60. And again, if we double tap on our Excel spreadsheet, you can see how the calculation is done. We take that principal balance of $1,060, multiply it by 6%, that gives us $63.60. And then again, we take that $63.60 and we add it to the principal balance, so that in year three, our initial investment has now turned into $1,123.60. You essentially are earning interest on your interest. That's the whole idea behind compounding. So when we look at this in terms of what's called the effective interest rate, okay, the effective interest rate is not necessarily going to be exactly what was stated as interest that's going to be earned, but it's effectively what was actually earned after we take into consideration compounding. So obviously when we have simple interest, our effective rate is going to be the same as our stated rate, because we are not compounding on top of our initial investment. We are simply earning the 6% that was stated in whatever investment we've selected, right? But look what happens when we talk about compounding. So when we compounded annually, meaning we, at the beginning of every new year, we started with a new initial investment that included our initial $1,000 plus any interest that we've earned. When we compounded annually, we ended up with a 3% interest rate, or I'm sorry, a 3-year interest rate of 19.1%. And that was simply calculated by taking the total amount that we earned, which was the $60 from year one, plus the $63.60 from year two, plus the $67.42 from year three. Everything that we earned, which was $191.02, divided by what our initial investment was, which was $1,000. That's the only amount that we put in initially, and then we just started earning on top of that year over year. If we take that $191 and divide it by 1,000, it gives us 19.1%. But again, that's a 3-year return. That is a 3-year return rate. So we need to take that and divide it by 3. If we take that and divide it by 3, what we can see is that our effective interest rate, assuming compounding annually, is actually 6.4%. So although our investment had a stated interest rate of 6%, our effective, or actually what we earned, was more than that. It was 6.4%, and that's because of compounding. Right? And you can see in the rest of the calculations too, the idea is that the more that you compound, meaning the more that you sort of start over again with a new initial investment amount, the more you do that in a year, the more you actually earn in returns. So you can see below, in year one, our when we compounded annually, we earned $60 worth of a return. If we compounded semi-annually, that means that we would earn half of the 6% every 6 months. So we would earn 3% every 6 months. But notice, at the end of the first 6 months, what happens is we take that $30 that we earned and we add it to our initial investment. So then we start to earn 3%, not only just on the $1,000, but on the $1,030 that includes the interest that we accumulated in the first 6 months, or the return that we accumulated in the first 6 months. So notice, if we compound semi-annually, twice per year, we have an interest rate of $60.60. $60.90 versus compounding annually where we only had a return of $60. And then look what happens when we compound quarterly. So notice in each of these examples, what we're doing is having to alter the interest rate or the return rate based on the number of compounding periods. So when we compound twice per year, we have to divide that rate by 2. We have to divide it in half. When we compound quarterly, we take that 6% rate, and you can see in the calculation, we take that 6% rate and we divide it by 4, right? We have to adjust for the fact that we're not going to earn 6% over 3 months in the first quarter. We're going to earn 1/4 of that 6% in that first quarter. So you have to adjust your interest rate as you compound. And then notice what happens. Again, after each compounding period, you see that interest amount being added to the principal balance, to the initial investment amount, and that over time, if we're compounding quarterly, in that first year, we would earn $61.36 versus if we only compounded semi-annually, we earned $60.90 versus if we only compounded annually, that first year we only earned $60. So those highlighted blue amounts are the comparison so that you can see that over time, what happens is that we earn more if we compound more times per year. So this can, there are investment opportunities where you're compounding monthly, compounding weekly, even sometimes compounding daily. And at the end of the day, the point is that the more that you compound within the year, the more of a return you're going to earn because you just continuously add to the balance of this initial investment. So as you add to the balance of that initial investment, you earn more on that initial investment. And again, this is known as the effective interest rate, the amount of interest that you actually earn, the rate at which that investment grows based on compounding. So again, effective interest here listed on our slide. We kind of already discussed that. Okay, so how do we use this to calculate and sort of take into consideration the time value of money? Well, we actually just did a future value calculation. If we had $1,000, so in this example, if we had $1,000 and we invested it at 6% for 3 years, and we compounded annually, meaning one time per year, how much would that grow to? What would be the future value? This $1,000 is our present value. And over time, what we can see is that that present value grows over 3 years to $1,191.02. That is the future value of $1,000 if we invested at 6% and invested it for 3 years compounding annually. So this is an example of a future value calculation. But the good news is that there is an easier way to do these kinds of calculations. Rather than creating a table like this, right? Imagine if you have an investment that you are compounding monthly for 10 years. You're not going to want to make a chart for that long a period of time, compounding monthly. It would just be too complicated. So the good news is that we have calculations both in financial calculators, but what I'm going to focus on is how to do these calculations in Excel that show us the future value of these invested dollars. So again, jumping back to my PowerPoint real quick. So the future value of a single amount, we're going to go through this example on the next Excel spreadsheet, on the next Excel tab. If we have $1,000 today and we can invest that $1,000, earning an average of 10%, how much would we have in 3 years? So again, we could, if I jump over to my second tab, we could, make a table here that shows, okay, we started with $1,000. We had a 10% interest rate, so that in the first year we earned $100, which means our new principal balance would be $110. Then we carry that over year 2. We had $110,000, right? So on and so forth. We could do that. Or we could use what's called a future value calculation in Excel. So notice here in this box, it says under the formulas tab in Excel, in the financial category, you can use FV. So if you go to the formulas tab under the financial category, you can see it gives you a laundry list of different formulas that you can use, right? FV you can see there right in the middle. As we get used to these though, another way that you can simply do it is by typing equals FV, And look, Excel automatically tries to sort of guess what it is that you're trying to accomplish. What type of calculation are you trying to do? FV stands for future value. That is the calculation that is going to allow us to calculate the future value of a dollar amount that we're investing today. So if I put, again, I'll start over again, equals FV, I'm going to tap on that FV formula, and the great news about Excel is that it pre-populates the formula for us. So it starts to basically ask you for all of the information. So what I'm going to do is I'm going to tap on each one of the individual items that Excel is asking me for. So first, Excel is asking me for the rate. If I tap on 10%, that's listed up there on cell B4. You can see that it automatically populates B4 into my formula. Then NPER stands for number of compounding periods. So notice this is not number of years, this is number of compounding periods. How many times are you going to compound interest or compound your earnings in the period of time that you have this investment? Because we are investing this for 3 years and we are only compounding once per year, we're going to just put in 3. That's our compounding periods. It's 3 years, but we're only compounding once per year. PMT stands for payment. This is if we were sort of putting a payment into the investment each and every year. So instead of just having one lump sum at the beginning of our investment period, let's say that, every year for the 3 years we were throwing in $500. That would be what PMT, what payment is. In this particular example, we don't have a payment. The only thing that we have is a present value. So for PMT, for this example, it's going to be 0. I don't have a payment that I'm making into that investment every period. What I have is, tap on PV, I have a principal amount. I have a present value. How much are you putting into the investment right now? $1,000. That's my PV. And then type, in these instances, type is going to come into play when we start to use that PMT, when we have a payment amount. So right now, type is just going to be 0. I'll explain what type is used for when we get into the last tab of our Excel spreadsheet. But right now, for these single value amounts where we're trying to calculate the future value, our type is simply going to be 0. If I do that, notice what happens in Excel. It gives me the exact same amount that I got when I used my my table here, right? So if we're saying that we have $1,000 and we're going to invest it for the next 3 years and earn a 10% interest rate, it will grow to $1,331. Now, why did this come out to be negative? Well, when we do these calculations in Excel, Excel is assuming one cash inflow and one cash outflow. So actually, what I should have done in this formula is created a negative for my PV, because that actually is a cash outflow for my investment. That's cash that I'm putting into the investment fund, which means it's cash out of my pocket now. And once I do that, once I make that amount negative in my formula, which I just did by putting a negative sign before the B3, if I hit enter, now look what happens. It gives me a positive amount of cash out or cash inflow. So one assumes, Excel assumes that one is going to be a cash outflow and one is a cash inflow. In this case, the cash outflow is the initial $1,000. I'm taking it out of my pocket and putting it into the investment account. And the cash inflow is going to be, at the end of 3 years, I'm going to get $1,331 back into my pocket. Okay, and so you can see up on the top that I also included semi-annual information. So let's go ahead and do the semi-annual compounding calculation and see how it changes that future value that we came up with. So again, I'm gonna use equals FV in my formula. I'm using a future value formula. My rate now, notice, is 5% because I'm only, for 6 months, I'm not going to earn 10% for 6 months. I'm only going to earn half of that. I'm going to earn 5% for 6 months. So 5% is my rate. 6 is my number of periods. Again, we have 3 years, but we're compounding twice per year. So my compounding periods, my NPER in my formula is 6. My payment amount is still 0. I'm not making any payments. What I have is a cash outflow PV, a present value of $1,000, and then again my type is 0. If I do those calculations, notice, if I'm compounding multiple times per year, then that's going to increase the future value of my investment. I'm going to be able to earn more based on the number of compounding periods that I have.